All right, here we go. We are note taking today, just out of our notes, like in your notes. We don't have a note sheet or anything like that today. But yeah, let's get at it. Okay. So warm up today. We're gonna find the area of a triangle with vertices of that. Anybody remember from yesterday formula or how we find the area of a triangle using matrices? And then 1. Okay, and what do we do with that? So I should set up a matrix, right? Okay, and so that matrix is going to be 3, -4, and 1. 5, 1, and 1. -2, 6, and 1. Right? Okay. Quinn, what am I going to do with that then? What am I going to do with it then? With what? Right? Okay? So we should probably pay attention then. Okay? We should probably, not have our side conversations going on, or otherwise we'll get moved up front here, and then it's kind of embarrassing for you. Right? Okay? Right? So what do I do with that then? What do you got, Kurt? I'm going to find the determinant of it, right? Okay? And then overall, what am I going to do to find the area with that determinant? Half of it. I'm going to multiply it by half, right? Okay? So the area of this triangle is going to be 1/2 the value of that determinant. Yes? Fine. So start by rewriting the first 2 columns, yes? And then what's our rule? Makes us want to jump. Crisscross, right? Criss minus the cross. Okay? So here's my first criss. 3 times 1 times 1 is 3. Here's my next criss. -4 times 1 times -2 is +8. Here's my next criss. 1 times 5 times 6 is 30. Then I've got to subtract off my crosses. Minus -1 times 1, or -2 times 1 times 1 is -2. Minus 3 times 1 times 6 is 18. Minus 1 times 5 times -4 is -20. And all of that still gets multiplied by 1/2. 3 plus 8 is 11, plus 30 is 41, plus 2 is 43, minus 18 is 21? 25? 25. Plus 20 is 45. Okay? So we got 45 in there. So we got 1/2 times 45. So the area of my triangle is 45 halves square units, or because it's a half, I would accept here 22.5 square units. Yes? Love it. Okay. So, if I wanted to solve this system of equations, right now, as you sit from your Algebra 1, Geometry, Algebra 2 background, how could we solve that? 3 ways. So yours first. Oh, go. Give me what you were going to say.
Actually, no, I don't know.
You were going to say graphing, right? Yeah, we could graph it. We could graph those two lines and see where they cross. Yeah, we could. 100%. Ooh.
I don't know if I'm saying exactly correct, but
Substitution is another way where we can solve one of the equations for one of the variables, plug it into the other one, get what that variable is, then plug it back in, get the other one. Yes, so it's really like two substitution curve.
you can cancel a variable.
Do you know what we call that one?
No.
It's elimination. Yep. Elimination is that way. So those are the three methods that you have. You've got graphing, you've got substitution, and you've got elimination. If we we can solve this really fast, right? Because we can go minus, plus in there, and so then these cancel out, and then that leaves me with 5y equals 5, so y is equal to 1, right? And then x minus 3 times 1 has to be 0, so x minus 3 has to be 0, so x has to be 3, right? So the intersection of these two lines is the point 3, 1. Agree with that? Okay. Check it back in both. Okay. 3 plus 2 is 5, works out. 3 minus 3 is 0, works out. Yeah? Okay. We're going to add another tool into your toolbox right now. It's going to be something called Kramer's rule. Now, Kramer's rule is made by a famous scientist who lives down the hallway. And so when you go into bio today and you see Mrs. Kramer, you can say, hey, we learned your rule today. Okay? Right? Really wasn't. It was made by some old dude way a long time ago. Okay? But what Kramer's rule says is that if I want to solve for the variable x, I am going to take the coefficients on the variables. Now, the kicker with this is it's got to be lined up. X, Y equals number. Much like elimination method, where you got to line everything up. Okay? So I'm going to take the coefficients of those, and I'm going to make a matrix out of them. And that's going to be my denominator. Okay? So we take our denominator, we call it D for the denominator. So matrix D is just the coefficients of your variables. Then, because I'm solving for x, I'm going to take that same, just wait to write this down though, I'm going to take that same coefficient matrix, but I'm going to replace the x, because these are the x coefficients, I'm going to replace the x coefficients with the two numbers that we have there. Now, we solved this system already, and we found that x was 3. So when I do this math, and we can quick do this math says this is going to be 5 times negative 3 minus 0 times 2. This is going to be 1 times negative 3 minus 1 times 2. 5 times negative 3 is negative 15 minus 0 is negative 15. Negative 1 times negative 3 is negative 3 minus 2 is negative 5. So this becomes negative 15 over negative 5. What is negative 15 divided by negative 5? if I want to solve for y, I would do the exact same thing. Oh, tough breaks. Maybe I can't get rid of that. I was hoping I could get rid of that, but apparently I can't because we'll leave that right there. And then, so then if I want to solve for y now, so now I would go the same denominator because that's my base where I start. Okay? But now instead of replacing the x ones, I'm going to replace the y coefficients. And again, 1 times 0 is 0, minus 5 is negative 5. This denominator will always be the same. So it should be the first one that you find, first determinant you find. It's always going to be the same. Negative 5 divided by negative 5 is 1. So we still get the point 3, 1. Now, you may be saying to yourself, why is Lynn's teaching us this funky method? And, well, the reason is, on 2 by 2s, it's much easier to do substitution and elimination. I know that. That's the way I do. But when you get to a 3 by 3, or a 4 by 4, or a 5 by 5, where you've got that many equations and that many variables, Kramer's rule actually becomes the simplest method. For now. Solving by matrices is actually the simplest method on those big ones. We'll teach you that later. Okay? So Kramer's rule looks like this then, put into play. Here it is with a bunch of letters and stuff so you can kind of follow along and fill in the blanks and all that fun stuff. I'll give you a minute to write this down. Okay? Now, the cool thing about Kramer's rule is the fact that pattern of what we just did, create your matrix D with your coefficients, that's your denominator. And then when you go to the top, whichever variable you're solving for, replace that column with the numbers that are, the constants, if you will. That pattern holds no matter what size of system you're doing with. So a 2 by 2, that pattern holds. A 3 by 3, that pattern still holds. Okay? So we've got all that. So what I want you to do now is I want you to solve this system of equations using Kramer's rule. And the nice thing about this one is it's easy to check because you can just check it back in the equation. And you know if you're right or not. So go for it. Try this one using the rule of the Kramer. -3, 1, 1. Right? Okay? And now I'm just going to find that right away. Okay? So that's going to be 2 times 1 minus 1 times -3. So that's going to be 2 minus -3. So that's going to be 5. So that denominator is 5. Okay? Okay? Then, since I'm solving for x, I'm going to replace the 2 and the 1 here with -23 and 0. -23 -23 times 1 minus 0 times -3 is that. And so then that gives me, what's that, -23? So I got x is -23. Now, easiest check is y is got to be positive 23. Let's check that. Y here is going to be, now I'm going to replace these two know that my denominator is going to be 5. So that's going to be 0. 2 times 0 minus 1 times negative 23 all over 5. And that's going to be positive 23. So we got 46 fifths minus 69 fifths. No. Yeah, negative 46 fifths minus. Yeah. And it works out. What? No. What? No. I was checking.
Oh.
Checking. So I went, oh, sorry. I'm going 2 times negative 23 is 2 times negative 23 is negative 46 fifths. Minus 3 times 23 is minus 69 fifths. And that's got to be negative 23. And so that's going to be negative 115 fifths, which is negative 20. So it works out. So the answer here would be negative 23 fifths and 23 fifths. Yeah, but same process, same things go on in a 3x3. Okay? Now, how this one did it, and this math is already done for you. Okay, so I'm just kind of walking you through it right here, right now. Okay. So they found this matrix D first, and that matrix D came out of the coefficients right there, just like it did in the 2x2. Okay. Except for some reason. Wait a second. That doesn't make any sense. That's not what that is. 2, 1, and 0. Oh, it's a different. Oh, okay. I'm like, wait a second, something's wrong here. But then I realized, got the brakes lens. It's a different problem. They went out of here. They went out of this one. Different problem. I thought they were the same problem. I got scared there for a minute because all of a sudden matrix D didn't match up. Woo! Be still my beating heart. Okay? So that's where they got those from. And then they just went through and they found all those. Okay? So, with that being said, let's do this for this 3x3 system of equations. Solve it using the rule of the Kramer. Okay? So my matrix D, which is important to find because that's all of 3 of your denominators, is going to be what? It's a 3x3 matrix. What is matrix D? Left to right, top to bottom. One, negative 2, 1, 3, negative 5, 1, 2, negative 2, negative 1. Okay? Find me that determinant. Find me the value of said determinant. All right, so 1, negative 2, 3, negative 5, 2, negative 2. All right, Chris's. So we agree that that is 5. We agree that that is negative 4. We agree that that is negative 6. Then crosses. That is negative 10. That is negative 2. That could have been that's right where I screwed up there. Yep. Zoe, I figured out where I screwed up. Yep. So 5 minus 4 is 1, minus 6 is negative 5, plus 10 is positive 5, 7, 1. So I get my D is 1. Yes? Okay. Right? Good. Now, I need to solve for X. Okay? So I'm going to say my X matrix is going to be now, instead of having 1, 3, and 2 there, I'm going to have 7, 14, and 3. So this is going to be 7, 14, and 3, and then negative 2 and 1, negative 5 and 1, negative 2 and 1. Okay? So now we got to find the value of that determinant. Negative 1 on the bottom. Yep, negative 1. Okay? So here we go with this one. 7, negative 2, 14. Why do the numbers got to be so big? 3 and negative 2. All right, here we go. 7, 5, and negative 5 and negative 1 is going to be 35. 2, 1, and 3 is negative 6. 1, 14, and negative 2 is negative 28. 3, negative 5, and 1 is negative 15, so I'm really going to add 15. Negative 2, 1, and 7 is going to be negative 14. Negative 1, 2, and 14 is going to be 28. So that's what, 29, 1, 2, 2. But that's over my 1 from before, so that means that X is 2. Agree with me on that. Okay? Y's or Z's? Which one you want to do next? Y. Okay. So Y then is going to be, now I'm going to have 7, 14, and 3 in the middle. 1, 1, and negative 1 there, and 1, 3, 2 there. Go for it. Find me what Y is, and I'll show you a quick way to find Z. 7, 3, and 14, 2, and 3. So then we've got negative 14. We've got positive 14. We've got 9. Yeah, it's all in there. Then we've got minus 28. Then we've got minus 3. Then we've got plus 21. 0, 9, negative 19, negative 22, negative 1. Negative 1 for Y?
Yeah.
Yes? Yeah? Yeah? Okay. Now, do we have to do Z? Why not, Luke? So keep those 2 back in. So we know that X is 2. We know Y is negative 1. So we could solve it by Kramer, or we could just plug it back in. So, I'm listening.
When you're solving for X, why is it negative plus or like?
Because this first one right here was 3 times negative 5 times 1, which is negative 15, right? And we subtract So it's Chris's, the blues,
Oh, God.
minus
Okay.
the crosses. So I just wrote, instead of writing minus negative 15, I wrote it as plus 10. Same thing up here, why I did plus 10 and plus 2. Okay. So 2 and negative 1, so 2 plus 2 is 4, so z is 3. Z is 3. Okay. Love it. That's some high quality resolution here. So I want to get to, we found some ACT problems that go along with matrices. And since most of you are juniors or seniors that are going to be taking the ACT once again, we wanted to expose you to said problems. Okay? So we need a value of x that satisfies it. Well, so that would tell me then that 2 times x plus 1 has to be 9. So what does x need to be? 4. Right? So x would have to be. Try that one. Yeah, you can get them all. Oh, yep, look at that. I can get them all in. Now, if this were me, what would I do first? What would I do first? Or what would you do first? Find some dimensions, right? Make sure it's possible. Okay? Because sometimes they'll throw a not possible as an answer. Okay? So first matrix is 2 by 2, right? Second matrix is 2 by 1, right? So my result is going to be a 2 by 1. So look at what happens. Because I know that this is a 2 by 2 and this is a 2 by 1, and my resulting matrix is going to be a 2 by 1, gone, gone, and gone. Just by not doing anything, you've eliminated and made this a 50% problem. 50-50 shot. Both of these first ones are different, right? Actually, all of them are different, right? So how many numbers how many times do I have to multiply? Once. I only got to find one element. Okay? So take top row, multiply it by first column, 2 times 2, negative 5 times negative 1. 2 times 2 is 4. 4 plus 5 is 9. The one that has 9 is this one, so it's got to be E. Okay? Matrices don't have to be scary, especially in standardized tests. Okay? While you're doing this one, I'm going to hand some stuff out.